Bu oturumda 5 tane konuşmacımız vardı. 3 tanesi tamamladık. Şimdi son ikisine geldik. İnşallah onları da süresi içerisinde tamamlayacağız. 4. konuşmacımız Baptiste Joufroy. Onun konusu Asset Management in SMARTGRID başlıklı olacak. Kendileri APLINES Uluslararası Satış Müdürü olarak bir şirkette görev yapmaktadır. Galiba İngilizce mi sunacak hocam?
Evet.
Tamam. İngilizce sunmasında bir mahsur var mı arkadaşlar? Yok,
Türkçe yok.
Gözüküyor.
Çok kısaca özet geçeyim. Ben Gökçer Çakır, Kurultay, Çaliştayi ana sponsorlarına Schneider Electric'te çalışıyorum. Akıllı şebekeler, enerji otomasyon departmanının başındayım. Bugün bizim kısa süre önce bünyemize kattığımız APLINES firmasının genel müdür yardımcısı Baptiste Joufroy, elektrik dağıtım sistemlerinde varlık yönetim çözümünü anlatacak. Sunum İngilizce olacak. Zaman da kısıtlı olmasından dolayı sorularınızı yemek arasında ve daha sonrasında alabiliriz isterseniz.
Şöyle yapalım, 15 dakika sunum, 5 dakikada soru cevap alalım. 20 dakikada zaten süre 20 dakika verilmiş. Thank you so much.
Okay. Yeah, thank you. So I'll just go through the agenda, and this is what we'll talk about today. So our topic is asset management for utilities, and we will cover why this is becoming a very important focus for utilities in Turkey, but also in other countries. I will then introduce a methodology to reduce asset risk and improve the performance of the network. And then I will cover 3 use cases about the digital technology and how they can improve the asset management methodology. Very quickly, APLINES, we're a Schneider Electric company, and we're a software company involved in asset management, and we're only focused on utilities. We've got an operation in Turkey, of course, and we've been awarded recently a project with ELEKTRİK about the asset management and calculating the asset health indices for all their equipment. I would like to start with some of the most common challenges that utilities are facing when they deal with asset management. The first one is about the asset portfolio itself. Most utilities, they manage millions of assets. If you look at the poles, the conductors, but also transformers. And of course, many of those assets are aging today. They can be 40, 50, 60 years old, and they will need to be replaced. And then they deal with different type of equipment, different brands, behaviors, and some complexity as well in certain assets, like transformers. But the big challenge is that data is not always available, and sometimes data quality is a challenge. So how can you make decisions about your assets if you don't have the data or the right quality of data? So that's a big challenge. But the other challenge is about regulation. Like in most countries, the regulators, they keep coming up with new requirements, for inspection, for maintenance, replacements. They're auditing as well, the CapEx, the OpEx. And most utilities, they have a more and more complex job to do because they've got to manage their assets, but they've got also to comply with regulation and lots of demands from energy regulators. So this is a picture that's evolving for every tariff period, basically. Another important factor that is very often, I would say, underestimated is the risk beyond the assets. Yeah? So everyone is aware that vegetation is causing issues in many utilities. Sometimes can be 15, 20% of failures, 30% of the failures can be due to vegetation. But if you look at the fires, storms, the impact of climate in general, it can be quite important on certain assets like overhead lines, but also transformers. So an asset management methodology should allow utilities also to consider those external factors and threats on their assets. And then the last factor I would like to mention, maybe this is not so prominent today in Turkey, but I think it will come, is the energy transition. Some countries have started to realize that when you start plugging electric vehicles on the grid, then you will add a lot of load on the asset, yeah, which means that your assets are going to age faster. Yeah, so I guess the message here is that on the long term, of course, you've got to consider the energy transition as part of the asset management strategy. I would like to quickly introduce a framework that is fairly, I would say, accepted internationally. So you have utilities in the US, in Europe, in Asia, who have started to use that framework. It was initially built in the UK by utilities and for utilities. It's called the CNAIM framework that you can see here at the bottom. Yeah, that's the CNAIM framework. And the key metric on that framework is what is called the monetize risk. Yeah, so basically for every single asset, what is the financial impact of an asset failure? So many utilities have started to look at the probability of failure of the asset. So what is the likelihood of this maybe pole or conductor or transformer to fail? And that likelihood can be based on certain data that you collect, but also the age, the location, duty factor. So there's all kinds of parameters that will that will come into the calculation of the probability of failure, but also vegetation and other kind of threats. But very few utilities are looking at the financial impact of a failure, because when you have to manage millions of assets, like if you have many poles or conductors, how will you prioritize, replacement and maintenance if you've got, thousands of assets to replace or to repair? Okay, so that's why considering the financial impact of a failure is very important. It can be in terms of repair cost, impact on the quality of service and potential penalties, but also safety and environmental impact eventually. Okay, so this concept is fairly simple to understand. And today there is a framework, again, called C9, that is coming from ISO 55000, which is an international standard for asset management. But today there is a framework that has been built for distribution utilities that is fairly now easy to implement, because it comes with a model that you have to fill, and that it will help you prioritize your maintenance and investments. I'd just like to stress on one thing, that asset management is a cycle, of course. Utilities, they deal with a short-term decision when they have to go and fix certain assets. They deal with the yearly programs, the 5 years programs during the tariff period, but also they've got to think strategically about the long term, right? So in asset management, you will find all those cycles, and it's going to start always with evaluating, the health and stimulating the future risk about the assets. Eventually, you can consider the impact of external risk, like vegetation. And then at some stage, that's going to help you to identify your big problems, okay? Because again, when you've got millions of assets, where do you prioritize and where do you start? So what is my top problem, my second problem, my third problem, based on the financial impact on my network? And then you can go in detailed analytics, analysis, per asset, per region, per asset category. And ultimately, what utilities want to achieve is to really prioritize the maintenance investments in terms of cost and benefits. And then ultimately, they want to create and generate the work plans for their teams. Okay? And that's a loop, because any utility will collect data. There will be new assets implemented as well. So that model is going to be refreshed on a regular basis with new data that's available, but also there's going to be new regulation from the regulator and new constraints that utilities have to consider. I'm just taking time. Yeah, I'd just like to cover a couple of use cases, because there are some frameworks that exist today, to make decisions on asset, and this is a framework I've showed you, the C9 framework. But what's really interesting today is that utilities have started to fill that framework with data coming from, let's say, new, recent technology. In that example, this is an example where companies are using data from drone about the conductors, about the fittings, and also they're using even data taken from the ground. High-resolution pictures, they can give a lot of information. And when that data is analyzed through artificial intelligence, computer vision, it can give very useful information about the health of the asset, obviously. And ultimately, that's going to feed a model where utilities can see on a map or in a matrix or dashboards, where are my hotspots, and from there you can really start to prioritize your replacement for the poles, for example, or replacing a line or a conductors. And again, the color of the dots, they will present the risk level, so the, black is high risk and the green is low risk, and you can simulate basically the cost and benefits of replacing a line, for example, based on the reduction of the risk and how much it's going to cost to replace the line. So that's about overhead lines. Another typical use case for utilities is transformers, because transformers is a very important asset of the network. It's also very expensive assets in terms of OPEX and CAPEX. So again, there are some models that you can use with data to evaluate the health of the transformer. But then you've got new sensors, you've got also the smart meters. So I think Turkey is deploying smart meters as well in certain regions. Those smart meters, for example, they will give very useful information about the health of the transformer, distribution transformer, obviously, right? So you will have information about which transformers may be overloaded, for example, and that information is going to flow into the model, and it will help basically you and utilities to better evaluate, the health of the transformer and what is the likelihood of failure and the useful, remaining life of the transformer. So in that project, for example, what we have realized is that when we plugged data from smart meters, we were able to have a better definition about the health, and that was without and with smart meters. And in that region, we could really detect the health of the transformer with a much higher accuracy. And again, ultimately, that's going to be data that will be used to feed intelligence to the maintenance teams about, hey, maybe you should start replacing that transformer because you're highly exposed in that area. Okay, but smart meters are very useful, but some sensors, of course, can be implemented. Grid devices as well can give information about the health of certain assets. Another use case, which I think is really interesting because it's always been, I would say, managed as a very operational use case, is vegetation, right? So some utilities, depending on where they operate, in the countryside or maybe in urban utilities, they have less that problem. They all deal with vegetation management and make sure that vegetation is not create some damage on the line, whether it's an encroachment or maybe a sick tree. There's all kinds of use cases in vegetation that can create some damage to the network. What's really interesting is that in the past, I would say 3-4 years, the satellite data has become much cheaper, and also you can get satellite data as well with a much higher accuracy, okay? And there's a huge wave of companies today globally, again in Australia, in Canada, in the US, in Europe, everywhere, who have started to use satellite imagery. And from satellite imagery, you can really configure some business rules and identify the areas which will be exposed to vegetation risk, basically. Okay, so that's a true image about satellite data. And again, the kind of polygons you can see that represent the kind of degree of risk on the assets. Okay, so once you've got that data, again, same methodology, you can feed your model, and then you say, oh, that line, I've got vegetation risk, and then also it's a critical line because maybe I've got some important customers connected to that line, like this university, for example, and then from there you can really help prioritize the maintenance. What you can see here as well is that it's now possible, of course, to look at, let's say, how much money you will spend on clearing the trees in that case, and also the benefit you will get in terms of risk reduction. And that's very much a core principle of asset management methodology, is to prioritize the operation based on the risk reduction versus what will be spent in terms of OPEX or CAPEX. For vegetation, of course, we're talking about OPEX, but that can be CAPEX as well for transformers or lines. Okay? It's now also possible to have, I would say, a fairly high-level model for tree growth as well, because you don't acquire satellite data every month. Today, it's still a bit too expensive. It will be available in a few years. But you can have tree growth models to really look at the projected risk in case there's no data for a year and you can see how the tree is going to grow, and then the risk is going to evolve as well, like a transformer, like any asset who's aging. Yeah, so I think this is my last slide. I think there's plenty of opportunities. So I started the challenges. I think there's plenty of opportunities for utilities in Turkey, and we're happy to start working with ELEKTRİK on that project. The first opportunity is to leverage those international standards because they've been developed for utilities and they're available today. They've been tested and developed for utilities, and they can be applied in Turkey as well. I think in Turkey there's 21 utilities, and there's also an opportunity to do some knowledge sharing because, you know, when there is a model for a transformer or maybe a best practice for certain type of asset, that methodology could be shared as well for mutual benefits. A key aspect is, of course, to think in terms of monetize risk. You know, the health of the asset is not enough as a concept. You've got to consider the financial impact of a failure, and that's really the best parameter you can use to prioritize work. And then the last point, digital technology. There's plenty of technology available today, but the asset management methodology will tell you where you have to focus, because no one can deploy satellite, drones, sensors, inspection everywhere at the same time. That's just impossible financially. But the asset management methodology will tell you where you have to focus, and based on those priorities, you can really decide where to collect data and where to implement technology, because this is where you get the best benefits. Okay, so again, through this approach, we combine the top-down approach that is strategic from asset management, but also the bottom-up where you can deploy high-tech drones, satellite data, sensors to have a better accuracy on your assets and the better information about the health of your assets. Thank you very much.
Okay, we also thank you for your invaluable presentation. It's great for us.
Thank you.
I think the audience will get benefit out of your presentation. We can get only one question for this speaker, please. Yes, please.
The reliability of the service that provide.
You can take the microphone, please.
So in my opinion, at least one of the most important things in the distribution system is the reliability of the service that provide.
Yeah.
Would you please make some comments how this assessment evaluation will impact the overall reliability of the service provided by the distribution companies? Thank you.
Yeah, thank you. It's a good question. You're right. Ultimately, it's about the quality of service. It's not only about the cost and benefits. But this is why this parameter is important, because when you have an operation of the asset, it's primarily to look at the reliability of service. Yeah. So sometimes it's called SID, SIFI. You have all kind of, I would say, parameters. But ultimately, this has to be quantified. So when this, I'm sure there's a transformer in front of the university. If the transformer fails, what would be the impact on the reliability of service? And that comes into the calculation of the monetized risk. So you're right. Ultimately, this is not enough. You've got to look at this aspect, especially the repair cost can be important as well. But this one is very often the number one parameter in the financial evaluation of the failure.
Okay, thanks again.
Thank you very much.
We have got one certificate for you, please. Oh, here. Oh, okay.